In this video, we are going to see about the queue data structure. Queue data structure is a linear data structure that is open at both ends and the operations are performed in the first in first out order. So if you have any doubt in what is a linear data structure, you can check my a video on the types of data structure in our channel. And queue is a list in which all additions to the list are made at one end and the deletions are made at the other end. And the operation is first performed on the element which is pushed first in the order. So this is the queue data structure where the two ends are front and rear end and the operations are enqueue and dequeue. You can see that operations detailed in a detailed manner now. And first we can see the principle of the queue, which is the first in first out. Queue is like a line waiting to purchase tickets, we can imagine, where the first person in the line is the first one to receive the ticket. So first come first serve, this is the principle followed in the queue. And the position of entry in the queue ready to be served, that is the first entry to be removed from the queue, is called the front or head of the queue. And similarly, the position of the last entry in the queue, that is the most recently added, is called the rear or tail of the queue. So these are the two ends, which are the front and rear ends. And we can see the characteristics of the queue and why we go for this data structure. Since this queue can handle multiple data and they are fast and flexible, and we can also access both the ends unlike other data structures like the stack. And then we can move to the basic operations on the queue. And first operation is the enqueue, which is the insertion of elements to the queue, and dequeue, which is the removal of elements from the queue, and front or peak. This is an operation that acquires the data element available at the front node of the queue without deleting it. And rear, this operation returns the element at the rear end without removing it. And is full, which validates if the queue is full. And these are the operations. We can see them in detail one by one. First, we can see the enqueue, which inserts an element at the end of the queue, that is at the rear end. The enqueue is done at the rear end. And it checks if the queue is full. If the queue is full, then return overflow error and exit. If this queue is not full, increment the rear pointer to point to the next empty space and then add the element to the queue location where the rear is pointing. So now if you are adding the element 5 to the queue, it is done at the rear end where 5 is added before the element 10. So this is an example we can understand from that. And next operation is the dequeue. Dequeue is the operation which removes and returns an element and that is at the front end of the queue. So dequeue is done at the front end of the queue. These are the steps. Check if the queue is empty. If the queue is empty, return the underflow error. And if the queue is not empty, access the data where the front is pointing and increment the front pointer to point to the next available data element. So if you remove the element 40, that is the dequeue is done only at the front end. So the 40, if the element 40 is removed, the pointer is incremented to the next available element in the queue. So the dequeue is done at the front end. So that element was the one which was first pushed in the queue. Since the queue follows first in first out principle. And next is the front operation. This returns element at the front end without removing it. And if the queue is empty, return the most minimum value. Otherwise, this returns the front value. That is the rear operation also returns the element that the rear operation returns the element at the rear end without removing it. Following are the steps and taken. If the queue is empty, return the most minimum value. Otherwise, return the rear value. So the next operation is empty, and this operation returns a boolean value that indicates whether the queue is empty or not. These are the steps. If check if front value is equal to 1 or not. If yes, then the return true. That means the queue is empty. Otherwise, it returns false, meaning that the queue is not empty. Since we are checking is the queue is empty or not. If is full, this operation checks whether the queue is full or not. This returns a boolean value that indicates whether the queue is full or not. These are the steps taken. Check if front value is equal to 0 and rear is equal to the capacity of the queue, and if yes, then return true. Otherwise, return false. Next operation is the size of the queue. This operation returns the size of the queue, that is the total number of elements it contains. So subscribe to my channel if you feel contented, like and share my videos with your friends. These are the operations of the queue in the queue.